Okay, Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Kelompok, and the lecturer is Dr. Anton Muhyiddin SPMP. And now I will present about two curriculum dari MPA Triple GS, VDSSK2 and VDSTA11 have distinct role in pathogenicity, microspheroidal formation, and stress adaptations. Okay, first I will present about introduction. Penicillin dahlia is a soil-borne fungus that infect more than 200 dicotyledonous plant species and cause devastating vascular disease. As vascular colonization and will development progress, V. dahlia produce melanin microsclerotia in the plant tissues, representing new primary inocular. However, melanin does provide protection from UV irradiation and temperature extreme, enzymatic disease, nutrient deprivation, and fungicide activities. Mitogen activated protein kinase MAPK cascades as key cores of signaling network in fungus and other eukaryotes. Mediate the signaling required to initiate infection-related morphogenesis and for a variety of cellular adaptation to diverse stimuli. In recent years, some of the key components of signal transduction in V. dahlia have been characterized. The objective of this current study was to confirm or establish function similarities in signal and to determine whether these kinases contribute to virulence in V. dahlia. Okay, the next I will present about the results of this paper. The first result is about VDST11 affects hyphal morphology in V. dahlia. Phenotypic observation revealed no major growth defects on various media. After incubation on basal medium or BM, areal mycelium growth was markedly reduced in the delta VDST11 strain versus the VDSSK2 strains. The germ tubes from the conidia of the VDSTA11 strain were confused with disproportionate branching and septation relative to the other strains. Given this finding above, we conclude that VDSTA11 plays an essential role in filamentous growth over solid surface in liquid media, while VDSSK2 has no obvious effect on filamentous growth and morphology. And the next result is about VDSSK2 and VDSST11 play distinct role in microsclerotial formation and melanin biosynthesis. Microscopic examination showed that delta VDST11 and delta VDSSK2 strain produce less melanin microsclerotia compared to wild type strain XS11 and the complemented strains. Further observation and quantification demonstrate that the delta VDSSK2 strain produce melanin microsclerotia in significantly reduced numbers. This result indicated that both VDSSK2 and VDSTA11 participate in microsclerotic formation, but the roles of two are distinctive. That is, VDSSK2 affect the number of melanin microsclerotia, while VDSTA11 regulates melanin produce or dispositioning during microsclerotial development. The next result is about dilatation of VDSTA11 impairs penetration, whereas dilatation of VDSSK2 affect fungal proliferations. Both delta VDSSK2 and delta VDSST11 mutants display significantly reduced disease severity. Figure 3b showed that the delta VDSTA11 strain was non-pathogenic, and while the delta VDSSK2 strain caused typical verticillium symptoms. Correspondingly, fungal hypha were not recovered from plants inoculated with the delta VDSTA11 strains, while the delta VDSSK2 strain could be isolated from vascular tissue and at a lower rate of isolation than those of the VDSSK2 combination strain and XS11. And the next result is about the delta VDSSK2 mutant phenocopies and delta VD-PBS2 and delta VDHOG1 mutants under various traces. The result demonstrates that the dilatation of VDSSK2, VD-PBS2, and VDHOG1 but not VDSTA11 cause hypersensitivity to high osmolarity and resistant to fluodeoxonil, suggesting that VDSSK2 function in the same signaling pathway as VDPBS2 and VDHOG1 in Vidaliae. The last result is about the VDSSK2, VDPBS2, VDHOG1 signaling pathway involved in high CA2 plus concentration tolerance. This finding indicates that expression of VDCRZ1 was at least partially depend on the VDSSK2, VDPBS2, VDHOG1 signaling pathway, and the misregulation in the expression of CRZ1 response to CA2 plus treatment could account for high CA2 plus sensitivity in the VDHOG1, VDPBS2, and VDSSK2 strains. Okay, the next presentation I will present about the discussion of this paper. Okay, I have summarized several points of this discussion. The first is the HOG-MPAP signaling pathway in fungi is important for sensing stressful condition and the activation of gene expression that enables fungi to resist osmotic stress and to survive under other adverse conditions. 2. The data present herein suggests that the STA11P MAP triple key or column in Vidaliae does not activate the SSK2, PBS2, HOG1 cascade. 3. The seminal discovery led to knowledge that Cerevisiae STA11 is required for filamentous growth, whereas SSK2 or SSK22 is not, which was consistent with our observation that the delta VDSTA11 mutant was detected in filamentous growth, while the delta VDSSK2 mutant had no obvious difference on filamentous growth. 4. In the present study, we provide several lines of evidence demonstrating distinctive function of VDSSK2 and VDSTA11 in microskeletal formation and melanin biosynthesis. 5. In the QRS study, we demonstrated that expression of VDCMR1 was significantly downregulated in the VDSTA11 mutant. We further found that expression of most melanogenesis association genes, including of VIYG1, was completely inhibited in the delta VDSTE11 strain. 6. We also found that SE11 plays a conserved role in patogenicity in Vidaliae. The QRS studies show that deletion of VDSTA11 causes low pathogenicity as the mutant fails to penetrate and develop invasive growth in Vidaliae. And the last 7, the results suggest that VDCRZ1 function is partly dependent on a functional HOG cascade, where the cascade directly influences VDCRZ1 gene's expression included by CA2+. And the last is the conclusion. So from the result and the discussion above, we can conclude that the two MAP triple key as VDSSK2 and VDSTA11 play some distinctive roles in signaling for microskeletal development, stress response, and pathogenicity of Vidaliae. Our findings provide compelling evidence indicating that VDSSK2 is necessary for signaling through the VDPBS2, VDHOG1 module, while VDSTA11 is not necessary for this pathway. Although VDSSK2 and the complex HOG cascade serve a more theoretical role as a regulator of fungal stress response, and VDSTA11 plays a key role in the infection process, crosstalk between MAPK cascades converge on microskeletal development. So that's all of my presentation. Thank you so much. Wassalamualaikum warahmatullahi wabarakatuh.